test it. This is a single phase stator, and this is the armature. So we are going to test the terminals now to see if our rewinding is in order. Supply terminals, these two. This is the plug. This plug goes to the AVR. This is our AVR here. So this plug comes here. Take a look at this point. It joins this point this way. That's how to connect it. So, but let's test it first of all. Now we are going to test the supply terminals, this and this. You should test positive to continuity test. So the meter is set to continuity already. Okay. So if it reads continuity, you go ahead and test for earth leakage. So no earth leakage, so the supply terminals are in order. Then let's go to this plug head. This section with a clip is the exciter terminal. It faces the exciter terminal, so let's test as well. The exciter is showing continuity reading, so it shouldn't have any earth leakage, and it shouldn't have any continuity with any other terminal. No continuity with the mains, no continuity with any other terminal. So the next terminal we are going to test is the voltage regulation terminal. Good. So you can see showing some reading on the meter. So that's all for that. So this is our armature. The armature made use of aluminium 23 gauge. So these are the two terminals. One terminal goes to one leg of the slip ring. This is a slip ring. The second terminal goes to the second leg of our slip ring, but unfortunately this slip ring is bad, so I'm going to change it. The bearing is bad as well, so I'll be changing this and this before coupling. So but we can test for continuity to see if the rewinding is okay. All right, is in order. So let's see how this works. This is our AVR. When we connect this here, this way, there are magnets at the side of an armature. So when this armature is rotating inside the stator, these magnets are going to induce some voltage, little amount of voltage in these windings. Okay, so from these exciter windings, this little voltage is fed into this AVR through these terminals. So when this little AC voltage enters here, this AVR has a rectifier circuit. All right, the output is going to be DC. As you can see, we have the positive terminal, and this is the negative. We have a brush. This brush is being placed this way. I hope you can see this clearly. To be touching the terminals of the slip ring. So positive of the AVR comes here. Negative of the AVR as well goes this way. So when this happens, this is DC. This is DC voltage. Now remember, little portion of AC from here enters the AVR, is rectified, and then we supply DC to this armature. When we do this, we make this armature an electromagnet. So instead of the little magnetic field we get from here, as we turn this into an electromagnet, we now get a larger magnetic field. So this magnetic field or magnetic flux, the larger quantity magnetic flux, is still going to be induced here. Then we get a bigger voltage, a bigger output voltage, which we collect from this terminal. So this is how it works. This is the connection. Thank you, guys.